Yo, what's up guys? Welcome back to another video. In this video, we're going to do something a little new. I've done challenges on my channel before, but I want to make an actual series on this where I show you guys how to solve challenges from HackerRank, LeetCode, and other stuff like that. So today we've got a HackerRank challenge. It's called Lonely Integer. It's pretty simple. It's one of the easy challenges, they say. So I've already attempted it myself. I'm going to show you guys how I attempted it. And then we're going to look at some of the optimal solutions and other ways that people have attempted it and solved it. Just before we continue though, I want to say that if you're not in our Discord server, make sure you join because we are doing challenges like these. Every week we're going to have a new challenge where you can try doing it on your own, and then we'll announce who the winners are, and you'll get even points for participating. And it's a great way for you to test out your skills and see if you can do these challenges and test out your skills. All right, so make sure you join our Discord server. There's a link in the description below. But let's get started. What I'm going to do now is explain what the problem is and how to solve it, or what needs to be done for the problem to be solved. And then I'll ask you to pause the video and try the problem on your own, and then you can come back and see how I solved it and other people solved it. All right, so this problem, like I said, is called Lonely Integer. And it says, given an array of integers where all elements but one occur twice, find the unique element. So with this example here, we have an array of integers, 1, 2, 3, 4, 3, 2, 1. We can see that some of these appear twice. And the unique element in that is 4 because it only appears once in the array. So all you have to do is create a function in any language that takes an array and then finds the unique element in it. That's why it's called Lonely Integer, because there is one integer who is alone. There's no other integer of that number. And I'll have a link for this problem in the description below so you can click it and solve the problem in the HackerRank editor, because they have it set up automatically so you don't have to get the input from the command line or whatever. You don't have to worry about that. You only have to worry about solving the problem, which is taking an array of integers and then getting the unique element out of it, okay? So anyway, once you come here, if you want to try solving it using HackerRank, just go down here and click, well, first of all, you can select a language if you want to. I'm gonna just do mine in Java because I like Java, so Java 8, and then click this to switch to their full screen editor here. And this is all the sample code, all of this here, and then right here, this will be empty for you. Right here is where you can put your code for the solution, okay? All right, so pause the video now, see if you can solve it using the language of your choice, and then come back to see if you solved it better than I did, or what the other solutions are, and you can maybe improve your solution, okay? All right, let's get started. This is going to be my solution before I show you some other optimal solutions. So the first thing you'll notice down here is that there are some other constraints of the problem here. So we can see that n, which represents the array size, is always going to be 1 or greater than 1, but also less than 100, okay? Interesting. And then it's also guaranteed that n is an odd number, so the amount of elements is going to be odd, and that there is a unique element. So with your lonely integer function that tries to find a lonely integer, it should always find one, okay? That's basically what that means. You'll also notice that this prototype that has been given to you called lonely integer by HackerRank, it passes in a list of integers rather than an array of integers, which is interesting. That's just something it does for Java problems. And that's okay because lists are way easier to work with than arrays. They're not the same, but the list is basically an abstracted form of an array. It's really the same thing at the end of the day, non-technically, but technically they're not the same thing. But in terms of their core concept of how an array works, it works the same way, okay? Hopefully that makes sense, maybe it doesn't, but either way, it's still basically the same problem, except that lists are easy to work with, so that's what we're going to use for this. You can change it if you want to, but this is the pre-made output, the pre-made code that it gives us, so we're just going to work with that, okay? So I know immediately I'm going to need to loop through all of the elements of this data here so that I can see if they're unique or not. So we're just going to do a simple enhanced for loop. So actually we'll do an indexed one, so integer I is equal to 0, I is less than data.size, and then I++. Okay, so as we look at each of the elements, we want to see if there's any occurrence, if there's any other occurrences of that element or not, okay? So the way we can do that is we can have an outside data structure called already looked at, or just checked or not, checked. That's going to be a new array list. And so this will contain all of the elements that we've already looked at so that we know if it's unique or not when we're trying to look for another one. And I'm looking for the brute force approach. I'm not looking for the best, the best time complexity solution or the best space complexity solution. I'm just trying to solve the problem at the moment. And then after you solve the problem, you can come back to it and look at, more optimized solutions to solve this problem, because I just like to do that because then you have a basis for improving the solution to your problem. So yeah, we're just going to solve it, and then we'll focus later on how to improve it, and I'll show you the different solutions that other people came up with for really clever ways to solve this problem without a lot of overhead. So anyway, as we look at each element, we're going to get the element that we're looking at. So we're going to have integer number, or just num, is equal to data.get I, and then we can say if checked contains number. If it does not contain number, that means that we have not already looked at it and checked to see if it's unique or not. And so what we're going to do is go through the rest of the array, go through the rest of the list, and check to see if there is another occurrence of this element. Okay, so what that means is that we'll have a second loop, so a nested for loop essentially. Integer j is equal to I plus 1. I'll explain that in a second. And then j is less than data.size, and then j plus plus. There we go. So the reason we're doing j is equal to I plus 1 instead of just j is equal to 0 is because since at this point in the iteration of this thing here, I can be anything, right? It can be 0, it can be 1, it can be 2, it can be 3, it can be 99. Because I has already gotten to that point, that means that every element before I has already been checked. So there's no reason in setting j to any index before I, because those have been already checked. So to save time, we're going to set j equal to the element directly after I, just so that we could start from there and then go from there. There's no reason to check anything before that. Hopefully that makes sense. And now we're going to see if we can find it. So we're going to do Boolean is found is equal to false. So if number is equal to data.getJ, and then we're going to do is found is equal to true, and then we're going to break out of the loop because we found a duplicate of the one that we're looking at, so there's no point in looping further. Otherwise, if it's not a match, then we'll just keep looping, okay? And then if we get done with this whole for loop here and nothing has been found, we can say if is found is equal to false. This means that we can just break out of the entire method because we have just found a unique element. So we can just do return num. Otherwise, we're going to do checked.add and then put a num in there, since now we've looked at it and we've determined that it's not unique. So now anytime we're looping, so now in the next iteration of the outer loop, we can see if a number is equal to any number within checked, then we can just skip over it because we've already looked at it and go to the next iteration. Otherwise, if it's a number that we've not already checked, then we can just go through this whole process again. So we're going to check every element after it to see if it's unique or not. If we find an element after it that is equal to the element that we're looking at, then we can break out and say we found it, and then we can just add it to the check and then move on to the next iteration. If we go through this entire loop here and we see that there is no other number that matches the number that we're trying to look for, then we know it's unique. It's the lonely integer, so we're going to break out and return because we found the lonely integer, okay? Otherwise, we'll just return -1, which will never be the case because like it says in the constraints down here, the array will always contain a lonely integer, so you should always be able to find something, but just to satisfy, this method here will return something, a dummy value, okay? So now let's run this to see if it works. Run code. There we go, so our test case is passed, great. So this one just passes in 1, so there's only one value, so just return 1. This one passes in 1, 1, 2, so 2 is the only integer, return 2. 0, 0, 1, 2, 1, the only integer is going to be 2, so return 2, there we go. Now let's do submit code, and it'll test a bunch of other cases, 9 different cases here. And they all pass. Great, perfect. So we know that our code works successfully. So that's my original code solution for when I first looked at this problem. It's very, very not optimized because you're essentially having a time complexity of, a worst case time complexity of big O of n squared, because you're having an outer loop, and then for each iteration of that outer loop, you're going to be looping again. So that's kind of crazy. So as your input grows, essentially the time that it takes to run this algorithm here is going to increase quadratically, I think. Quadratically? You get the point. Anyway, so it's very much not optimized, so what I'm going to show you now is some different, more optimized solutions to the same problem here. Let's go ahead and take a look. So you're probably familiar with the basic operators in Java, the Boolean operators. So you're probably familiar with the basic Boolean operators that we use in everyday programming. Of course you are. So if you have true and true, this will be true because both sides have to be true. If you have true or false, that's going to be true. If you have true or true, that's also going to be true. And then there's true XOR true, that's going to be false. And then you have true XOR false, that's going to be true. XOR means exclusive OR, so it's an OR operation except that it's exclusive, meaning that only one has to be true for it to be true. So if they're both true, then it's going to be false. If one of them's true, then it's going to be true, okay? So it's very similar to OR, except that they cannot both be true on either side. So with that understanding, we can then use the bitwise operator, which is this. So if we have a number 56 and then bitwise OR, it's called bitwise OR, and then another 56, that's going to be equal to 0 because they both have to be true, or one of them has to be different than the other. But if we have 0 and then bitwise OR and then 56, that's going to be equal to 56 because one is different than the other, so it's going to give us that number. With that concept in mind, let me show you how this would be solved. So this is a basic array I came up with here. Now let's apply the XOR, exclusive OR bitwise operator onto it, okay? So behind the scenes, it's basically using binary. That's how you can think of it, because that's why it's called bitwise. So we have to find the binary representation of each of these numbers and then apply the operator to it. So we're going to start at 0, right? The default number of the sum variable is going to be 0, right? So that's where we're going to start. So let's go ahead and apply this. So first is 0, and then we have 1, so that's going to be 0, 1. And that'll be just equal to 1 in binary, because here we do it digit by digit. So 1, 0, bitwise of that. Bitwise OR of that is just going to be 1 because they're both different. And then 0, 0. You can ignore it. It's not actually there behind the scenes. We're just using that so they're lined up, okay? So 0, 1, and then we'll continue. So that'll be 0, 1, the result of that. And then 2. So the binary of 2 is just 1, 0. So that's going to be equal to 1, 1, because they're both different, which is 3 in binary, okay? So now we have 3 in binary for the sum. And so we're going to do 1, 1. And then now we have 3 up here, as you can see. So we'll do 1, 1 again. So that's 3 bitwise OR of 3. That's going to be equal to 0 because the bitwise OR of 2, because they're both the same on each digit, right? So 1, 1, 0, 1, 1 is 0. So that's how that works. So now it's reset back to 0. All right, so we'll continue again. So now it's going to be the sum is equal to 0 now in binary, and then the next number is just 1, so 0, 1. So now it's going to be equal to 1 again, right? Just in binary and in, what's it called, decimal system, just regular human numbers. And after that, the sum number is going to be equal to 1, and then the last number is going to be equal to 3, okay? So we're going to do 0, 1 for the sum, and then 3 is 1, 1. That's going to be equal to, so the first digit here is 1 and 1, so that's going to be equal to 0. The next digit is 0 and 1, so that's going to be 1. And that's going to be equal to 2 in binary. Or 2 in decimal, rather, excuse me. So 1, 0 in binary, and then 2 in decimal. So that's the answer. 2 is the only integer of this array here. And it's a little tricky, but it's also really cool and really simple how this works. It only requires one pass of the array, the input array, and it gives you the answer at the very end. You'll have the final answer. So that's way more efficient than my solution because I had a big O of n squared solution because I had an outer array, and then inside of the outer array I had, or outer loop, excuse me, inside of the outer loop I had an inner loop. So it's basically iterating twice, worst case. Not completely twice, but the point is that it grows in that manner. Big O of n squared, okay? But in this case, it's big O of n just because it's only going once through the entire array or list. And then you have the final result of 2, okay? There are other short solutions that you can find out there, but I think this one is the most optimized because it doesn't require any outside data structures, and also it requires one pass, like I said, and also it's just very simple. So it's the best that I've seen so far. If you have any other good ones, then feel free to show me. But this one just blew my mind. It's really freaking cool. I've never actually used the exclusive OR operator in programming, like on purpose, so it was really cool to see this for the first time and actually learn how it would apply in this situation. Now I'm going to show you one more solution that I found to be interesting. It's not as optimal as this one here, but it's basically between this one and my solution. So it's like medium in terms of optimization, I believe, okay? So let's go back to this here, and we're going to just delete this code and redo it. Okay, so instead of having all of this, so originally in my solution, I had a list, right, that keeps track of what I've already looked at. For this one, we'll have something similar. So instead of a list, we'll do a map. So we'll do map integer, integer. and this map will keep track of the frequency of each integer inside of our data input, okay? So frequency is what we'll call this. FREQ is equal to new hash map. All right, so every time we find a new number inside of our input, we're going to add it to the map and then set it to 1. And then if we come across the number again, we'll just increment it by whatever we want to increment it by, okay? And then after that, once we're done looping through the entire input, we'll go back to our frequency map and check to see for the value that equals 1. So there's only going to be one key that has a value of 1 because there's only going to be one lonely integer, all right? So this should only require one pass over the data, but it also requires an outside data structure, so it's less space optimized. You're using outside data, so you're allocating more data depending on the input that you're being given. So yeah, okay, but let's go ahead and try this out. So we're going to do for integer num frequency, or no, not frequency, data, the input, and for each number, we're going to do if frequency dot contains key num. So if it contains it already, then we're just going to increment it because we found it a second time. So we'll do frequency dot, and then there's a replace method we can use. So replace takes a key and a new value, right? Yeah. So frequency replace, and then the key is going to be equal to num, and the value is going to be equal to the current value plus 1. So we'll do frequency dot get, and then pass in num again, and then plus 1. So that should hopefully increment it. Otherwise, if it's not in the map already, we're going to add it to the map by doing frequency dot put, and then put the num key and then the value of 1, which is the first, the default, because we just found it for the first time. And then at the very end here, like I said, we're going to go through our frequency map and check to see for the value that equals 1. We're going to get the key of that. So frequency dot get, and there's actually there's a contains value method here that tells you if a value is present, but that wouldn't really help us because we need to get it can tell us whether the value is present, but it can't give us the key from that. I don't think there's a method for that. So I'm sure there's an easy way to find it, but we're just going to go ahead and loop through this and then manually find it from the map. So I guess in that case, it's still it requires 2 passes technically. It's not as bad as like a loop with another loop inside of it, a nested loop, but we still have to do 2 different passes, which is not as efficient. So there's different ways you could do this, but we're going to do map entry, and we're going to do integer, entry, and then frequency dot get, or entry set. There we go, entry set. So this will just give us each of the key value pairs, and we're going to be able to loop through that now. We're going to say if entry dot get value is equal to 1, then we're going to do return entry dot get key, and hopefully that should work. Let's go ahead and find out. And we need to return something by default, but it should never reach this point anyway. Let's try it out. There we go. So the sample code works, or the sample test cases works. And now let's do there we go. So now it works perfectly. All right, cool. So that solution worked. Again, we're just looping through all of the elements in our data array, our input, and then adding it to a frequency map. So that just contains all the unique numbers and then how many times they appear in the input. And then at the end of that, we're going to go through that map again, find the one that has only a value of 1 and get the key, which is the number that it's associated with. And there we go. So this requires 2 different passes, both independent of each other, but because they're independent, I think because they're not nested, that would be big O of n plus m or n plus n, something like that. I have to brush up on that stuff, but that should be what it is. It should be more efficient than my solution, but not more efficient than the Bitwise XOR operator that we saw, okay? And there we go. So those are the 3 different solutions that I want to show you. There are more. If you want to see more different solutions, you can go to the leaderboard tab here on HackerRank, and you can view a bunch of crazy, awesome solutions, or you can go to discussions, and people post solutions here as well. Some really cool ones with Python and other languages you can take a look at if you're interested in that. But yeah, hopefully you were able to solve this problem. Hopefully you were able to come up with your own solution, and hopefully this was fun to try and do on your own. Stay tuned for more episodes like this, and again, make sure you join our Discord server so you can get in on these challenges to take part and have some fun, okay? Yeah, thanks for watching. In the description below, I'll leave the link for this HackerRank post, and that's all I got. So see you guys next time, and if you say anything about my mustache in the comment section below, I will ban you from my life. Goodbye, everybody.